Hi to everyone. I am Dr. VNSR Venkateswara Rao, working as an Associate Professor from the Department of Chemistry in Institute of Aeronautical Engineering, Dundigal, Telangana. So today I would like to give the section on the conductometry. So first of all, before starting the session, what are the topics covered in today's session? The topics which are covered in today's session are mainly introduction to the conductometry. After that, we discuss about what is the principle involved in the conductometry, especially conductometric titrations. Next, we discuss about what are the advantages. After that, we see what is the working of conductometry. Next, the topic is what are the types of the titrations involved in conductometry, and the topic is finished with what are the advanced applications of the conductometry. Okay, let us start the introduction to the conductometry. So first of all, it is one of the electrochemical method of the analysis used for the determination of a measurement of the electrical conductance of an electrolyte solution by means of a conductometer. So first of all, based on this conductometer, we can determine the endpoint of a reaction with the help of the conductivity measurement. So that's why it is also called as electrochemical method. That means the chemical reactions based on electricity. The chemical reactions which are based on the electricity, that is called as electrochemical methods. So electrochemical methods means the best example for a volumetric reaction is nothing but redox reaction. So redox reaction, which involves the both oxidation and reduction reactions simultaneously takes place. So in this case, we observe that at one place the loss of the electron takes place, at another place gain of the electrons takes place. So finally the movement of the electron takes place from one place to another place. So this is entirely takes place by the chemical reactions. So that is called as a electrochemical methods. And other examples of electrochemical methods are potentiometry, pHmetry. All of this comes under category of the electrochemical methods. And for the present section, conductometry, it is based on the measurement of the electrical conductance of an electrolyte solution. So that means, first of all, what is conductivity? Conductivity is nothing but C is equal to 1 by R. That means mobility of the ions. It is the inversely proportional to resistance. So conductometry is the measurement of the conductivity of a solution due to mobility of cations and anions towards the respective electrodes. That means in this case, we observe mainly two types of the electrodes. One is anode and another one is the cathode. The anions are moves towards the opposite respective electrode, whereas cations also moves to the opposite respective electrode. So there is a similar attraction and repulsive forces in between the cations and anions. After that, we see conductivity is also inversely proportional to reciprocal of the resistance. Already we discussed about, and the units are the mohms. Why? Because for the resistance, the units are the ohms, but conductivity C is equal to 1 by R. So the units becomes ohm inverse. Okay. So it is also called as mohms. Okay. So this is the units for the conductivity of a solution. And the conductivity of a solution is mainly depends upon the four factors. The four important factors are the first one is the concentration of the solution, and second one is the charge of the ions, and third one is the size of the ions, and fourth one is the temperature of the solution. The first one, concentration of a solution. Whenever the concentration of a solution increases, the conductivity also increases. For example, from 0.001 molar solution to 0.1 molar solution and 0.1 molar solution. So whenever the concentration increases 0.01 to 0.1, 0.1 to 1 molar solution, the concentration of the solution will be increased. Whenever the concentration of the solution increases, the total number of the ions also increases. Whenever the ions will be increases, the mobility conducted by the overall ions also increases. Next one, charge of the ions. Charge of the ions means, so whenever the charge increases, for example, whenever the positive charge increases on the ions, what happens? It reduces the size of the ions. Whenever the size of the ions will be reduces, what happens? The mobility of ions also increases. So conductivity also increases. And the third one is the size of the ions. Whenever the size of the ions increases, the overall size of the ions will be has increases, and the mobility will be decreases. And the final one is the temperature. So temperature means it is also when temperature increases, the mobility of the ions also increases automatically. The conductivity of the solution also increases. So out of four factors, the three factors are directly proportional to conductivity, and one factor is inversely proportional to conductivity. Now we see the first factor, concentration, and second one, charge on the ions, and third one, temperature, all these three factors are directly proportional to conductivity. One and only size of the ions is inversely proportional to conductivity. So these are the four factors which affects the conductivity. Concentration, charge of the ions, and temperature will be directly proportional to conductivity, and size of the ions will be inversely proportional to conductivity. Okay, so this is purely depends upon the overall ions occupied by the place. So that is called as the conductivity. Now we see the types of the conductivity are mainly three types of conductivity. One is the specific conductivity, and the second one is the molar conductivity, and third one is equivalent conductivity. Equivalent conductivity. Okay, so first of all, specific conductivity. So it is the conductivity offered by a substance having square centimeter area. For example, if you consider a sphere, the length of the square is centimeter and breadth of the square is also centimeter. Now area is equal to length into breadth. So overall centimeter into centimeter, it has square centimeter area. So we consider the square. Within the square, there is a small ions. So they will be moved to in different directions. That may be either upward direction or downward direction or left direction or right direction. Because of all these movements, what happens? They causes the some mobility. That mobility is called as a specific conductivity. That means it is offered by a 1 square centimeter area. So it will be reduces when size of the ions increases, because the overall ions occupied by the area will be decreases, and it affects the mobility of the ions. Finally, it causes the reduction of a conductivity. So that's why the specific conductivity will be decreases when size of the ions will be increases. And second one is the molar conductivity. So molar conductivity means it is offered by a substance having 1 molar solution. 1 molar solution means it is having a fixed concentration. So it will be directly proportional to both concentration and charge, size, and also temperature of the solution. And equivalent conductivity. Equivalent conductivity means it is offered by a solution having 1 equivalent weight of a solution. That means equivalent weight of a solution. That is called as a 1 normal solution. This is also directly proportional to charge, size, temperature, and concentration of a ions. Only specific conductivity is very inversely proportional to size of the ions. So this is the about the type of the ions and what are the factors affected in different types of the conductivities. Now we see what is the principle involved in the conductometric titration. So the main principle involved in the conductometric titration is to determine the end point of a reaction, especially in neutralization reaction by taking a example. So now I take the best example is strong base and hydrochloric acid, strong acid. Finally, it neutralizes to give the salt, strong electrolyte NaCl, and neutralization product nothing but water. Okay, so this is the principal equation of a conductometric reaction. It initially starts with strong base, reacts with the strong acid to give a strong electrolyte, nothing but sodium chloride, with water byproduct. So the determination of a endpoint of a titration by means of conductivity measurements is known as a conductometric titration. That means the conductometric titration mainly involves the to determine endpoint of a reaction with the parameter nothing but by measuring the conductivity. So it will be based on the mobility of the ions. Okay, so during the course of a titration, what happens? The conductivity of the solution changes. So since there is a change in number and mobility of the ions, so that mobility is purely depends upon the total number of the ions involved in particular area. So at the end point of a titration, there is a sharp change in conductivity of a solution by the intersection of the two lines. So we see the graph. We draw the graph for the conductivity, which is taken on a y-axis, and volume of the HCl is taken on a x-axis. So, and we observe the points like initially the conductivity will be decreases. After the end point, the conductivity will be gradually increases. And by the intersection of these two lines, these two lines to get a end point of a reaction, So from the end point of a reaction, we can determine the unknown concentration present in a solution. So by the intersection of the two lines in the graph of the conductivity versus volume of the titrant solution is added. So these are the parameters which are taken on a horizontal axis x and vertical axis y. On vertical axis we take a conductivity parameter, whereas x axis we take a volume of HCl is added. So by taking points and draw the two straight lines and intersection of the two lines to give a end point of a reaction. And the basic diagram is the hydrochloric acid, strong acid will be taken a burette, and the unknown concentration solution soda hydroxide will be taken in a beaker. The conductivity cell which is placed in a base solution, it is a conductivity cell, and it is connected to a conductivity meter to observe a physical readings. So that means the conductivity is purely depends upon a mobility of ions. And finally, based on to measure the conductivity with the help of the mobility of ions and to determine a end point of a reaction. Now we see what are the advantages of a conductometry. So first of all, the main advantages of conductometric titration are its applicability to very dilute and colored solutions and to a system that involves the relative incomplete reactions. So first of all, it should not only applicable to a colorless solution, even though in the colored solution also to determine the end point of a reaction, and the reaction which is not completed by the manually, the reactions also completed by the conductometry and to determine the end point of a reaction. And for example, which neither a potentiometric nor indicator method can be used for the neutralization titration of the phenol, a conductometric endpoint can be successfully applied. So the main advantage of this instrumentation. So the instrumentation advantages are when compared to classical methods. In case of conductometry, there is no need of the indicator. And second one is applicable to low concentrations. So these are the main two advantages of the conductometry when compared to classical methods of analysis. The first one is no need of the indicator even in the colorless or colored solutions, and second one is the applicable to very low concentrations. And now we see what is the second advantage. The conductometric titrations can be used with colored solutions where endpoint cannot be seen. That means and can be used where there is no suitable indicator. In the case of the colored solutions, there is no suitable indicator. But by using conductometry, there is no need of indicator and to determine an endpoint of a reaction. And no indicators are required, and therefore a color solution can be conveniently used. That means the conductometric titration color solutions accurately carved out the very dilute solutions, and where indicator color change is not sharp. That means in the case of the manual titration, nothing but classical titrations, the endpoint should not give the sharp endpoint, even though such a type of titrations is also done by using the conductometric titrations. And the third one is conductometric titration can be used with many weak solutions and also weak acids. That means weak solutions means, for example, if you consider weak base, ammonium hydroxide, and weak acid, acetic acid. Even though in the weak acids and weak base, the titration is highly impossible in case of the classical methods of analysis, but by using conductometric titration, this type of the titration is also possible. So this procedure is very functional in the titration of solutions that are very dilute solutions and even for the weak acids. That means already discussed about the solutions which are very low concentrations, that means dilute solutions, and the strength of the acid is very low. That means weak acid and weak base titrations is also possible by using the conductometry. Now we see the next advantage of this conductometric titrations are, for weak acids and weak base, no suitable indicators are available, but by using conductometric titrations can be conveniently carried out. For example, in the case of the strong acid and strong base, HCl reacts with sodium hydroxide, there is no problem by using classical methods of analysis. But by using weak acid and weak base, that means ammonium hydroxide is a weak base and acetic acid is a weak acid, to give the final product of neutralization reactions. What happens? CH3 COO NH4, ammonium acetate plus water molecule. So in this type of titrations, it is highly impossible to determine the strength of the product, nothing but ammonium acetate, but by using the conductometry, it is possible. So that is the additional advantage of the conductometry, even in weak acid and weak base. Okay, and second one, it gives the more precise endpoint. More precise means more accurate endpoint compared to a classical methods of analysis. And the endpoint of a titration is very pointed and correct when compared to a few other titration processes. That means the corrections are very less in case of the conductometry to determine a endpoint of a reaction. And more accurate results are obtained by using conductometric titrations because the endpoint is determined graphically. Not only it will be taken a direct reading and from a number of measurements and not from a single measurement as in volumetric titration. So in this case, already we discussed about in the previous slide, that is the endpoint is determined with the help of the so many readings by taking various types of the results. So by using all these points to get a intersection of a two lines to get a endpoint of a reaction. So that's why the endpoint of a reaction is not only depends upon even in single measurement. And next advantage is the titration can be used with colored and opaque solutions in which endpoint cannot be seen with the naked eye. So that means in the case of the colored solution, the endpoint is not directly determined. And in case of the colorless solutions, if both are colorless, for example, hydrochloric acid and sodium hydroxide, both are colorless solution, in that case, what happens? We cannot observe by the endpoint for the naked eye. Even such type of solutions is also carried out to get a endpoint of a reaction by using conductometry. And this type of titration is appropriate for colored and turbid solutions. So turbid solutions means the solutions is not clear, even that we observe the endpoint is very difficult. So such difficulties are also overcome by using the conductometry. And the endpoint of the titration with usual indicators cannot be experimental simply with by human eye. So even though the naked eye is not visible to the some of the endpoint of a reactions, that reactions is also done by the conductometry. And the next advantage is volumetric titration does not give the correct endpoint for the polybasic acids, while conductometric titration can be conveniently used in the such cases. For example, basic acids, for example, monobasic. Monobasic means hydrochloric acid. Polybasic. Polybasic means first of all we consider a dibasic and tribasic. Yes, so dibasic acid means sulfuric acid H2SO4, and tribasic acids means phosphoric acid H3PO4. So even though such type of titrations, the titrations with dibasic acids like sulfuric acid and tribasic acid, phosphoric acid, these two acids comes under category of the polybasic acids. Even such type of polybasic acid titrations is highly impossible by using classical methods of analysis, nothing but volumetric titration. But by using conductometry, the titrations with polybasic acids like sulfuric acid and phosphoric acid is also possible by using this type of the instrument. And also conductometric titrations can be used where there is no appropriate pointer. Since the endpoint is detected graphically, no endostatic examination is essential near the end point. And also the procedure of the conductometric titrations has many applications such as used in acid-base titrations, the number one, and second one redox titrations, and also the third one complexometric titrations, and the fourth one is the precipitation titration. That means this complexometric reactions or complexometric instrument is not only applicable even in a single volumetric titrations, it also applicable to the different types of the volumetric titrations, acid base neutralization or redox reactions, and also complexometric, and finally precipitation titrations is also done by the complexometric reactions. Now we see what is the working of the conductometry. So this method is based on the conductive measuring principle, where two electrodes are positioned opposite from each other and alternative voltage, that means an AC voltage, is applied to the electrodes, which generates a currents in the medium. The cations are moves to a negatively charged electrode, while the anions are moves to a positively charged electrodes. So that means the oppositely charged cations are moves to a respective electrodes. So while the anions moves to a positively charged electrode, the more free charged carriers the liquid contains, the higher the electrical conductivity and the current flow is. However, the ion concentration becomes too high. This leads to a mutual repulsion of the ions and as a reduction of a current. So this effect is called as a polarization. That means whenever the acid or base, for example HCl plus NaOH, to gives rise to NaCl plus water. So that means initially what happens, this HCl will be dissociates into H plus and Cl minus ions, and this NaOH, Na plus and OH minus ions, and finally these are linked with the oppositely charged ions. That means Na plus and Cl minus, H plus and OH minus, to give a ions like Na plus and Cl minus and H plus and OH minus ions. So this type of the anions are moves towards the oppositely charged ions. That means whereas anions moves to a positively charged electrode and the cations are moves towards the negatively charged electrodes. So this type of the opposite charged electronic species will be takes place, and this type of the effect is called as a polarization effect. And to compensate the polarization effect, the electrodes measurement uses two additional electrodes that serves as a passive or observers. So this is the overall diagram. So this is a resistance box and headphones and source of the alternating current, and there are two electrodes, one is anode and second one is the cathode, and the overall cell will be dipped in a conductivity cell. So these current less electrodes measure the potential difference in the medium, which depends upon the conductivity. So the connected transmitter uses the measured potential difference and the given current to calculate the conductance and finally electrical conductivity. So this is the very important. Finally, the electrodes measure the potential difference. So potential difference will be takes place whenever the charge transfer will be takes place. That means at one electrode oxidation takes place at and the electrode reduction takes place, and the resultant ions, nothing but anions, are moves towards a positive electrode, whereas cations are moves towards a negative electrode. So Finally, it measures because of the mobility of ions to measure the conductivity. So, with respect to the mobility of the ions, there occurs a potential difference in between these two electrodes like anode and cathode. Finally, it gives the observed EMF, that means conductivity. So, with the help of conductivity to determine a end point of a reaction, that may be either neutralization reaction or precipitation reaction or also redox reactions. Now we see what are the types of the conductometric reactions. There are totally 5 types of the conductometric reactions: acid-base titrations, precipitation titrations, and complexometric titrations, and replacement reactions, redox reactions, and complexometric reactions. So this is about the types of the reactions. There are totally 5 types of the reactions: acid-base titrations, precipitation titrations, replacement titration, redox titrations, and complexometric titration. Now we see the first one, acid-base titrations. So by neutralizing either acid or base with known concentration of either acid or base, the titration may be used to determine the unknown concentration of an acid or base. So by using conductometry, we can determine 4 categories. That means strong acid, strong base, the first category, and second category is weak acid, strong base, and third category is strong acid, weak base, and fourth category is weak acid and weak base. So strong acid and strong base is examples are HCl plus NaOH. Okay, and weak acid strong base means acetic acid plus NaOH, and strong acid weak base means HCl plus ammonium hydroxide, and also weak acid weak base means acetic acid plus ammonium hydroxide. All these types of the titrations are possible by using the conductometric reactions. And second one is the precipitation reactions. So the forms of a titration that include the formation of a precipitate throughout the titration technique are known as a precipitation titrations. So in the precipitation titration, the titrant reacts with the analyte to form a insoluble material that is nothing but a precipitate. So the condition for the precipitate is the solubility product Ksp is less than the ionic product. So that is called a unsaturation condition. That means supersaturation. There are 2 conditions. The first one is a solubility product is equal to Kw. And the solubility product is greater than the Kw. So that means this is called as a unsaturated condition, and Ksp is equal to Kw is called a saturated condition. Ksp is less than the Kw is called as a super saturated condition. This super saturated condition is also called as precipitation takes place. So for the purpose of precipitation, the condition is always the solubility product is less than the ionic product. Okay, and third one is a replacement titration. So the replacement titration is used when the direct or back titration does not produce a sharp endpoint of the analysis. So it is mainly used to titrate the like oxalates, benzoates, and phosphates, etc. So by using all these types of the categories comes under category of the replacement titrations. So and fourth one is the redox titration. So redox titration means the reaction simultaneously takes place both oxidation and reduction reactions. So redox titration is most commonly used for the laboratory method for identifying the concentration of unknown analytes, and it depends upon an oxidation reduction reaction among the analyte and titrate. So that means oxidation. Oxidation means loss of the electrons, and reduction means gain of electrons. So finally, the electron moves from oxidation to reduction. So there is a transfer of the charge. Because of the transfer of the charge, there is a potential difference that takes place. That potential difference causes the mobility of the ions. Finally, with the help of that mobility, we can determine the conductivity of a solution. So with the help of conductivity, we can determine a end point of a reaction. So this is the overall mechanism involved in the redox reaction. And next one is the complexometric titration. In case of the complexometric titration, what happens? The complexometric titration is a type of volumetric analysis in which a colored complex is a formation of endpoint. That means that endpoint of a titration. And the complexometric titrations are particularly applicable to determine the metal ions in the sample solution. So that means mainly the complexometric titration, the principle is metal ion is initially reacts with the indicator to give a complex, and that is react with the EDTA solution. So this EDTA solution will be replace the indicator from the metal ion. Metal EDTA complex is formed with the releasing of the free indicator. So with the help of this metal EDTA complex, we can determine the concentration of a metallic ions present in the solution. So this is also possible by using the conductometric titrations. Okay, now we see what are the advanced applications of this conductometric titration. So it is mainly used to check out the water pollution. That means it is mainly applicable to determine precipitation reactions by using chloride determination, bromide determination, and also the cations like calcium, magnesium present in the given sample solution. All of these comes under category of a to determine a water pollution, especially in the case of the hardness of the water, and also it is applicable to the complexometric reaction. Such complexometric reactions is also done by the conductometric instrument, and it is also used to determine the salinity of a sea water. Salinity means the water which contains a amount of a salt. That means that salinity, for example, if you consider the concentration of a sodium chloride solution present in a given sample, so that salt water content is also determined by using a conductometry, even by using a sea water. And it is also used to determine the alkalinity of a fresh water. Alkalinity means the amount of the ions present in a water which will be reacted with the acid solution. So that is called the alkalinity. And also conductometry is also used to determine a quantitative analysis of a compound. So quantitative analysis means it involves the all types of the reactions like neutralization reactions, that and precipitation reactions, and complexometric reactions, and redox reaction. In all these reactions, all the methods of a quantitative methods of the analysis comes under category of the volumetric analysis. And it is also used to tracing the microorganisms in the foodstuff. So that means it is not only applicable to tight methods and also used for the to determine the quality of a food for the measuring the amount of microorganisms present in the food. So these are the advanced applications of a conductometry. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.